Welcome to the Bare Metal Cyber CCISO Prepcast. This series helps you prepare for the exam with focused explanations and practical context. Cloud security is no longer a niche concern. It is now central to the cybersecurity strategy of nearly every modern enterprise. Organizations are increasingly adopting cloud services to achieve scalability, flexibility, and cost efficiency. Whether consuming software as a service, developing applications in platform as a service environments, or deploying infrastructure in IaaS platforms, cloud adoption introduces unique risks that must be addressed directly. Cloud environments are decentralized and can be provisioned quickly, which means vulnerabilities can proliferate just as fast if not properly governed. Without visibility and policy enforcement, these risks multiply. Cloud security protects data, workloads, access, and infrastructure across distributed environments. It enables compliance in complex regulatory contexts and supports the business's ability to innovate securely. For organizations aiming for resilience, agility, and digital transformation, cloud security is foundational, not optional. The CISO plays a central role in defining and enforcing cloud security strategy. This includes establishing policies that apply to all cloud environments, from development to production. The CISO must align cloud security practices with enterprise risk appetite and regulatory requirements, ensuring controls scale with the organization's growth. Vendor selection, onboarding, and oversight all fall under the CISO's domain. Cloud contracts must reflect security expectations, including those defined in shared responsibility models. The CISO also has a duty to report on cloud risk exposure to executives and governance bodies, translating technical issues into business terms. Cloud security cannot be treated in isolation. It must be fully integrated into the organization's governance, compliance, architecture, and incident response program. With the right visibility and control, the CISO ensures that the benefits of cloud adoption are realized without compromising security posture. Understanding the differences between cloud service models is essential for effective security. In a software-as-a-service model, the customer has limited control and focuses primarily on access management, data protection, and user activity monitoring. Examples include productivity tools, CRM platforms, and HR systems. In platform-as-a-service, the customer is responsible for the application code and data, while the provider manages the runtime and infrastructure. Security must address configuration, development, and data layers. In infrastructure as a service, the customer controls operating systems, applications, network configuration, and user access. The greater control in IaaS also means greater security responsibility. For each model, the CISO must understand who is responsible for securing which components and ensure that controls are tailored to the level of access and risk. Service-level agreements must define security expectations, audit rights, and incident handling responsibilities. Core cloud security controls form the technical foundation of any cloud program. Identity and Access Management, or IAM, governs user access, API permissions, and service roles. Fine-grained permissions and role separation reduce the risk of overprivileged access. Encryption is essential for protecting data in transit and at rest. Cloud Key Management Services, or KMS, enable encryption management, while some organizations use Bring Your Own Key, or BYOK, for additional control. Logging and monitoring are provided by cloud network tools like AWS CloudTrail or Azure Monitor, but these must be centralized and reviewed to support detection and response. Network segmentation in the cloud is enforced through security groups, firewalls, and transit gateways. Container and serverless environments require security policies embedded into DevSecOps pipelines. The CISO must ensure that these controls are implemented consistently and monitored across accounts, regions, and cloud providers. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Cloud Security Posture Management, or CSPM tools, support continuous visibility and enforcement. CSPM tools scan cloud environments for misconfigurations such as open storage buckets or publicly exposed services. They alert security teams when deviations from baseline policies occur and help ensure that new services are deployed securely from the start. These tools also support least privilege enforcement by detecting unused or overly permissive roles. Automation allows for real-time compliance checks and remediation actions, reducing human error and manual effort. Asset inventories, classification, and tagging are also managed through CSPM tools, which provide the visibility needed for policy application and risk analysis. The CISO must lead efforts to assess posture regularly and tie findings to risk registers and governance reviews. Cloud vendor risk is a key part of third-party risk management. The CISO must evaluate cloud providers' security practices, certifications, and operational transparency. Important certifications include ISO 27001, SOC 2 Type 2, and FedRAMP for government workloads. Contracts must include specific language around data security, breach notification, resilience testing, and audit support. Data sovereignty is another concern. Data stored in or transmitted through different jurisdictions may be subject to varying laws. Providers must be evaluated for how they handle data localization, retention, and access by third parties. Ongoing monitoring of vendor performance and SLA adherence is critical. Where security gaps exist in vendor capabilities, risk must be documented and accepted at the appropriate level. The CISO must maintain clear ownership for vendor oversight and ensure that third-party risks are addressed within enterprise GRC processes. Data protection in the cloud starts with knowing where data resides and how it flows. Sensitive data must be classified and governed with appropriate access controls. Data loss prevention, or DLP, tools help detect and prevent sensitive data from being stored, transferred, or accessed inappropriately. These tools are especially useful in SaaS platforms and cloud storage systems. Backups must be encrypted, tested regularly, and stored separately from production systems to prevent ransomware or accidental loss. Data lifecycle policies govern retention, archival, and deletion, ensuring compliance with regulations such as GDPR or HIPAA. Geographic restrictions should be enforced through region-based controls to ensure that data is not processed or stored in jurisdictions with higher legal or privacy risks. The CISO ensures that these controls are not just implemented, but verified through monitoring, reporting, and governance. Security must be integrated into cloud architecture and design. Zero trust principles are particularly relevant, assuming no trust, verifying every access attempt, and minimizing exposure. Security controls must be embedded into infrastructure as code templates and CI/CD pipelines. This approach ensures that security policies are enforced automatically during deployment, reducing configuration drift. Segmentation, access control, and monitoring must be defined early in architecture planning, not bolted on after services go live. Using reference architectures from NIST, the Cloud Security Alliance, and cloud providers help standardize practices and avoid misconfiguration. Architectural reviews must be conducted regularly to accommodate changes in business needs, application design, or regulatory requirements. The CISO must be involved in architecture approval and ensure that security design is aligned with enterprise risk appetite and compliance posture. Cloud incident response requires specific planning. Visibility into cloud logs, authentication events, and service activity is essential for detection and triage. Incident response teams must develop cloud-specific playbooks that outline steps for containment, investigation, and recovery. Escalation paths, communication protocols, and evidence handling procedures must be adapted to cloud environments. Legal hold processes must support data preservation, even in transient or elastic workloads. Investigators need to be trained in using CloudNet tools, APIs, and forensics methods. Coordination with the cloud service provider is often necessary, especially when incidents involve underlying infrastructure or cross-tenant impacts. The CISO ensures that cloud incident response is rehearsed, integrated into the broader IR program, and supported by both internal expertise and provider relationships. The CISO exam includes scenario-based questions and terminology that reflect current cloud security challenges. Candidates should be familiar with concepts such as CSPM, IAM, shared responsibility, BYOK, and zero trust. Scenario questions may involve cloud misconfigurations, vendor contract review, or response to cloud data exposure. The CISO's role includes securing the enterprise's cloud strategy, integrating it with compliance requirements, and ensuring cross-functional governance. Cloud security intersects with audit, incident response, risk management, and architecture review. Success on the exam depends on demonstrating how cloud security decisions support enterprise resilience, legal obligations, and long-term operational agility. Thanks for joining us for this episode of the Bare Metal Cyber CSO Prepcast. For more episodes, tools, and study support, visit us at baremetalcyber.com.